In this next bit, we're going to talk about the very edges of our solar system, the Kuiper Belt and the Oort Cloud. You might have heard of a term or read it in your book called trans-Neptunian objects. So these are objects that orbit at the sun at a greater average distance than Neptune. So trans-Neptunian just means that it's further out than Neptune, and Neptune's the furthest planet away from our sun. Okay, the Kuiper Belt is a disk of material at the edge of our solar system. So here we have our solar system and we've got the Kuiper Belt out here. Okay, the Kuiper Belt contains more than 1,000 icy bodies left over from the formation of our solar system. And guess who is a member of the Kuiper Belt? Pluto. And beyond the Kuiper Belt, which is, again, this kind of disc-shaped region at the edge of our solar system. Beyond that is the Oort Cloud, which is this shell surrounding our entire solar system of billions of icy planetesimals. If you remember way back from the beginning of the semester, we saw the Oort Cloud when we were doing our order of magnitude view of our universe. Okay. So what we call short period comets, or comets that have an orbit around the sun that's less than 200 years. These short period comets usually originate from the Kuiper Belt, this ring of material at the edge of the solar system. But beyond that, in this sphere of icy bits surrounding our solar system, long period comets usually originate in the Oort Cloud. So within the Kuiper Belt, there are plenty of objects that don't have these long elliptical orbits, but rather have more stable orbits, more like that of the planets. And one example of that is Pluto. So Pluto is a member of the Kuiper Belt. And here's this beautiful image of Pluto that was taken by the spacecraft called New Horizons. Now, if you watch the Crash Course Astronomy video that I asked you to watch for the reading quiz about the Oort Cloud, that Crash Course Astronomy video is a little bit old by about 4 or 5 years. And at that point, New Horizons hadn't yet passed by Pluto. But when New Horizons reached Pluto a few years ago, it took this beautiful high resolution of Pluto's surface. And we know that Pluto has craters, it has mountains, it has valleys, it has land features. And it's got this beautiful kind of like heart shape on its side. It's saying, hello, we love you, solar system. And New Horizons also caught an image of this object that we call Arakoth. And we think of it as really an asteroid. And it's made up of these two lobes right here. This is what we call a contact binary asteroid. So instead of having two separate asteroids like smush into each other and shatter into a million bits, these two pieces orbit each other very slowly, and then they eventually come into contact and they fuse into one. So this one lobe was one asteroid on its own, and this other lobe was a second on its own, but over time they sort of merged together to become one object. So I've been talking about comets, but I haven't really identified exactly what they are yet. So comets are icy bodies which spend most of their time in the outer solar system, either originating from the Kuiper Belt, if it's a short period, or originating from the Oort Cloud, if they're long period orbit comets. Comets have a particular structure. They have, so this, would be the center of our comet in here. The comets have a tail, which is a narrow column of gas and dust that stretches over 100 million kilometers or more. Okay, so here are the tails back here of one particular comet. And then we have another part of the comet that we call the coma, which is kind of like the atmosphere of the comet. So if here, this is the icy nucleus of our comet, which is basically, you can think about them as being like dirty snowballs that are about 10 kilometers across, and they contain most of our comet's mass. That's the nucleus of the comet. And then surrounding that is our coma, this atmosphere of fine gas, of thin gas. And then beyond that, then we end up having the beautiful tails that come off of the comet. The cool thing about comets is that their tails are always pointed away from the sun. Why is that? Well, here we have the sun, and here we have a comet coming out from very far away, and it's going to come around and make its closest approach to the sun. So remember, comets have orbits that are the most elliptical orbits of objects in our solar system. So this comet is going to come around, make its close approach to the sun, and as it does that, radiation from the sun, or what we call the solar wind, stream of particles coming from the sun, are interacting with that comet. And the solar wind interacting with the comet causes the tail of the comet to appear. And then you get the tail of the comet always pointing opposite the direction in which the solar wind is streaming outward and away past the comet. And so as the comet comes in close to the sun, we see its dust tail is always pointing away from the sun. Now, every time these comets pass by the sun's heat and the solar wind is going to erode them. So every time they swoop in close to the sun, they're actually losing a little bit of mass when they do that. And every time we have a meteor shower, the meteor shower is a result of a comet filling its orbit with emitted dust and the Earth passing through that dust-filled orbit. These meteor showers happen routinely throughout the year. There's always a meteor shower near my birthday called the Perseids meteor shower in August. And we're going to end this mini lecture by talking about Comet 67P. It's this beautiful comet that we started our engagement check with. So the Rosetta mission arrived at this comet, Comet 67P, in 2014. So here's the Rosetta spacecraft, and then it dropped this little guy here called Philae to land on the surface of this very comet, Comet 67P. And so this little lander here landed on the surface of Comet 67P in 2016. And whenever it did that, this little video that you're seeing in the upper corner, this is the video captured by Philae as it landed on Comet 67P. It looks like snow, right? Here it's sitting, literally sitting on the surface of this comet. So here's the sort of cliff edge of the surface of the comet. And it looks like we're inside a snow globe. But what's happening is that there's dust particulate floating around, coming off of the surface of the comet. Interaction with the solar wind is causing this. And also we have some of these streaks here are what we call cosmic rays. And cosmic rays are high energy protons and atomic nuclei, which move through space at nearly the speed of light. And those cosmic rays are interacting with the detector on the lander here. And so we can see that here as sort of this beautiful snow globe effect.